Hi everyone, Ravi this side. Welcome to Engineering Adda. So this is the third video of the Java 8 series. In the first video, we have discussed about the Java 8 features in brief. In the second video, we have discussed about one of the Java 8 features, which is lambda expression, in a very detailed manner. In this video, we are going to discuss on the functional interfaces in Java 8. So first of all, we are going to discuss what is functional interface and what all the functional interfaces are already present in Java and what important functional interfaces introduced in Java 8 and how they are working. Everything we are going to discuss in this video through the practical implementation. So let's get started for that. So first of all, let me try to go to the functional interfaces slide and try to brief you about the functional interfaces. So let me try to go there. So functional interface. So what is functional interface? An interface that contains only one abstract method, or you can say single abstract method, is known as functional interface. But there is no restriction. You can have n number of default and static method inside a functional interface. There are a couple of already existing functional interfaces in Java which are runnable, callable, comparable, and comparator. This runnable interface have only single abstract method called run. Similarly, callable interface has call and comparable have compare to and comparator has compare. Let me try to go to the next slide and try to show you the other important functional interfaces that are introduced in Java 8, and we are also going to practically implement those. Okay, so when I'm going to create a application in IntelliJ, then I will try to show you or like walk you through this runnable, callable, comparator, and comparable as well, and we'll show you the single abstract method of these interfaces. But as of now, let me try to go to the next slide and discuss about the important functional interfaces that were introduced in Java 8 and how they are behaving, what are they, and how we can implement it. Everything we are going to discuss now. So let me try to go to the next slide. And first of all, we are going to discuss about the predicate. So these interfaces return a Boolean value based upon the evaluation of a condition. So predicate is also a functional interface which have a single abstract method. Its name is test and its return type is Boolean. Okay. So these interfaces return a Boolean value based on the evaluation of condition. Predicate takes an argument of type T and returns a Boolean result. So when it is saying that predicate takes an argument of type T, that means inside the predicate functional interface we have one abstract method which is test. It takes an argument and its return type is Boolean. In the last line you can say it has a single abstract method Boolean, its name is test, and it takes T as a argument and returns the boolean as a result. Okay, so let me try to summarize about the predicate. So predicate is a kind of functional interface having a single abstract method test. This test method takes T as an argument and returns the boolean value. Okay, as simple as that. When we are going to create the application, we'll try to implement these things as well. Now let me try to go to the next slide and show you about the consumer. So this is a second important functional interface of Java 8. Its name is consumer. These interfaces accepts an input but does not produce any result. So this functional interface consumer has a single stack method called accept. It takes T as an input and does not have any return type. So that is why we are telling that these interfaces accepts an input but don't produce any result. Okay, so the return type of this single abstract method accept is void. Consumer accept an argument of type T and performs an operation without returning any result. And here it has a single abstract method called accept. Its return type is void and it takes a argument as T. Okay. Now let me try to go to the next slide, and the third one is supplier. This is also a functional interface introduced in Java 8, and it has a single abstract method get and its return type is t. It does not take any input as an argument. Okay, so these interfaces don't take any input but produce a result. Supplier produces a result of type t. It has a single abstract method get and its return type is t. Okay, now let me try to go to the next slide and discuss about the function. This is one of the most important functional interface of Java 8, which is function. The function interface is a part of Java util function package, which has been introduced since Java 8 to implement functional programming in Java. It represents a function which takes in one argument and produces a result. Hence, this functional interface takes in two generic, namely as follow. T denotes the type of input argument and R denotes the result type of the function. So this functional interface has a method apply, which is a single abstract method, and it takes T as argument and it has a return type R. Okay, so this is about the functional interfaces of Java 8. These are the four most important functional interfaces introduced in Java 8. We have discussed about their how they are working, what single abstract method they have, and what are their return type, what the argument they take. So briefly, we have discussed about these four functional interfaces. Now it's time to go to the IntelliJ and try to create a application, and then through practical implementation, we are going to discuss these functional interfaces. Okay, how we can like write or how we can implement the abstract method of these functional interfaces. Okay, so let's get started. For that, let me try to come out of the slide, and here we are in the IntelliJ. Now let me try to create one application here. So go to the file, new project, and let's say it is a functional interface. Like project name is functional interface in Java 8, something like that. And let me select the art type to quick start, create this application, open it in a new tab, and just wait for a few seconds to do the necessary configuration. Once it is done, then we can start doing the development. Okay, let me try to close this one and just wait for a few seconds. I will also walk you through the already existing functional interfaces like callable, runnable, comparator, comparable, and will show you how they are written and what are the single abstract method they have. So we'll see. I think it is good. Now go to the source, main, go to this application. Let me try to walk you through the runnable interface first. So just type runnable here, go inside it, and you can see this is the interface and it is a functional interface. So it is annotated with @functional interface and it has a single abstract method which is run. Okay, so if you want to go to the callable, just put callable here, and let me try to go inside this, and you can see this is also a functional interface and it has a method call and its return type is v. Okay, so similarly you can also walk you through like you can go through the comparator and comparable. If you want me, let me try to show you those things as well. So go to the app, let's say comparable, go inside it. You can say this is the interface and it will come up. It has one abstract method compare to. So if it has only single abstract method, it's not necessary to provide like what I would say annotation called @functional interface. Like if you want to create a functional interface, you have to be like it should be a functional it should be an interface and then it should have only single abstract method in it. Either you are defining @functional interface annotation at this class or at this interface or not. It is not necessary, but it is always necessary to have this interface only single abstract method. Okay, and there is no limitation on the default and the static method. So this is also a functional interface. It has a single abstract method compared to. Similarly, if you want to check for the comparator, let me try to go there. Like predicate, consumer, function, supplier. So all of those important functional interfaces we are going to discuss now. So one by one, we are going to discuss each functional interfaces. First of all, we'll see what are the methods inside these functional interfaces and how we can use them in a traditional way, and then through the lambda expression how we can implement those methods we are going to see. And then finally we'll also discuss how those functional interfaces can be used in the stream API. Okay, so let's get started for that. So first of all, let me try to go to the app. Like predicate, consumer, function, supplier. So all of those important functional interfaces we are going to discuss now. So one by one, we are going to discuss each functional interfaces. First of all, we'll see what are the methods inside these functional interfaces and how we can use them in a traditional way, and then through the lambda expression how we can implement those methods we are going to see. And then finally, we'll also discuss how those functional interfaces can be used in the stream API. Okay, so let's get started for that. So first of all, let me try to go to the app and remove this and just create here a package called functional interface. Okay, and come into it. Let me try to create one class called, let's say we are going to start with the consumer. So consumer functional interface demo, something like that. It's a big name, but yeah, let it be. Now let me try to create this main method, and here let me try to walk you through the consumer first. Consumer functional interface. Okay, so consumer, let me try to remove this consumer. Yeah, if you'll go inside it, you will see that this is a functional interface and it has one method accept, and it is taking one argument t, but its return type is void. This is what we discussed, right? So now what we'll do, we'll try to implement this consumer interface in this class, and how we traditionally try to implement the interface in a class, that is what we are going to do here. So let me try to remove this and let me try to implement the consumer here. So consumer, and you have to provide one argument here, so let's say it is integer, and you have to override the single abstract method here. So just implement it and then we are good. Why we are getting the error, let me try to see. Okay, so some Java related thing, set language level to 8. I'm using Java 18 here and we have to set it to 8. Okay, so we are good now. So what we did, we have created one class and we are traditionally, like how we try to implement a interface, we are doing the same thing here. Later on, we'll try to implement the single abstract method through the lambda expression. But as of now, we are traditionally, how traditionally we are implementing the interface, we are doing the same here. So what we did, we have created one class, we are implementing the consumer, and if you want to implement this consumer, you have to override the unimplemented method, which is single abstract method except. Okay, so now if you want to provide something here, let's say just want to print something. This is accept method, let's say this is accept method of consumer. and let's say its input argument is, let's say, integer. Okay, let me try to minimize this. So what we did, we have overridden this except method and provided some implementation here. Now, how traditionally we'll try to call this method, we are going to do the same. So just create a reference of this class and let's say equal to new consumer, sorry, new consumer functional interface, and with the help of functional interface demo we are just going to call the accept method, and sorry, accept method, which we have implemented downside. Okay, now you have to provide some value here, let's say 40, and just try to run this and then see. Okay, this toolkit target, why we're getting this, just come over. Okay, let me try to remove this and run it again and then see. So here you can see we are getting the message like this is accept method of the consumer, its input argument is 40. So yeah, this is how traditionally we'll try to implement the interface and try to override the method, and then practically we can call that method. So this is what we are doing, but this is the traditional way. But when we are using a functional interface which are introduced in the Java 8, then there is a uses of lambda also, right? With the help of lambda expression, we can directly call this functional interfaces single abstract method. So that is what we are going to do now. Okay, so let me try to remove all this code and just let it be now here. Let me try to comment it out and just undo this implementation. And now what we have to do with the help of lambda expression, we can directly call this accept method. So that is what we are going to do. So if you want to call this accept method, you have to first convert this method in a form of anonymous function. In the previous video, we have discussed what is anonymous function. Anonymous function is a function without any name and return type. So if you want to convert this accept method of the consumer, then you have to make it in the form of anonymous function. So just let me try to copy this and come here into the main, paste it out. Let me try to remove this comments and just remove this implementation as well. So now we have the accept method of the consumer. Now we need to convert this in the form of anonymous function. So we have to remove the name and its return types and its modifier, and you can also remove the type of the input. So just remove it. Let's say this time either you can keep it as an integer or you can give any variable name. Let's say we are going to give the name as t. Okay. Now you have to introduce the lambda expression here, which is arrow sign, and then you have to provide the body of the lambda expression, which is open and close bracket. Now this is the lambda, and you have to provide the implementation of the accept method inside the body of the lambda. So let's say you want to print something here. So let's say this is the implementation of accept method of consumer. Okay. Okay. Let it be like this. Okay. And something like also you can say and its input argument is t. Okay, so this is we have implemented. Now you have to assign this whole lambda expression to the reference of the consumer. So you have to create a reference of the consumer here. So just create a consumer equal to this, and you have to provide a colon here. Okay, so we are good now. So what we did, we took this single abstract method, we converted that single abstract method in the form of anonymous function, and then we applied the lambda expression there, and then we provided the implementation of the accept method inside the lambda body, and we are good now. Now with the help of consumer reference that we have created, we can directly call the accept method and pass the argument that you want to pass. So let's say this time we are passing the argument as 25. Okay, and now let me try to remove this piece of code, and now you can run it and then see. So here you can see this is the implementation of accept method of the consumer function, and its input argument is 25. So it's working fine, right? Through the traditional way also you can implement the consumer interface and implement its single abstract method and use it out, and through the lambda expression also you can minimize your code and implement it. Okay, now because this is like this has only a single argument, you can remove this open and close parenthesis. Okay, and because this body has only single line, you can also remove this open and close bracket, and you can make this in a single line. So just come up like this, and if you run it, this will work good. Okay, you can see this, it is working fine, and the code is also reduced. But if you have more than one argument, you have to put this parenthesis, and if you have more than one line of code in the body, you have to put this open and close bracket in the body. Okay, so this is how you can implement the consumer accept method through the lambda expression. Now allow me to summarize the consumer for you. So consumer is a kind of functional interface introduced in Java 8. It has a single abstract method accept. Let me try to go to the accept and show you. So this accept is taking one argument t, and its return type is void. So it is not returning anything. Okay. So this accept method takes one single argument and its return type is void. That means it does not return anything. We have seen that through the traditional way and through the Java 8, through the lambda expression, we can directly implement this accept method. Okay. Now I have a question in my mind where we can use this consumer or where we can use this accept method. So there is a use cases of this consumer in the stream APIs. That is what we are going to discuss next. Now let me try to create a list of integers and try to convert that list of integer in the form of a stream, and then with the help of for each we are going to print list of the integers one by one. Okay, so that is what we are going to do here, and in the for each method we can directly pass the consumer in it. Okay, so I will also show you the use case of the consumer in the stream API there. So let me try to comment out this piece of code and then try to create a fresh list of integers. Let's say it is L, and let's say arrays dot as list, and let me pass some integer value here. Okay, now let me try to convert this is list into the form of a stream, and then with the help of for each we can print this element inside this list one by one. Okay, so if you'll come here to the for each, you can see this for each is taking consumer as an argument, right? So let me try to go inside the for each first and show you. So if you'll go to the for each, you can see this for each is taking the consumer as an argument, right? So what you can do is directly you can pass this consumer that you have created here in the for each. So let me try to uncomment this piece of code. And what we did here, we have implemented the accept method of the consumer and we have the reference consumer here. Okay. So directly you can pass this consumer to this for each method. And what it will do, it will try to print out each element one by one. Okay. So let me try to do it and then show you. So if you'll come here, you can see this is the first one which we are printing here when we are calling this consumer.accept method. Now after that, when we are converting this list in the form of a stream and then we are calling this for each method and inside the for each method we are passing this consumer reference, then this is calling the accept method by itself and it is passing the elements from the list one by one, and that is why you are getting these things. This is the implementation of the accept method of the consumer function and its input argument is one. You can see the second and the third, fourth and the fifth. So each element is being called one by one in this for each method with the help of this consumer, and this consumer is calling this accept method that we have implemented here. Okay, so this is the use case of the consumer. In the stream API, in the for each method, you can directly pass the consumer and then implement it. Okay, now if you don't want to pass this consumer like this, what you can do, you can directly take this piece of code and then directly pass it here in the for each. Okay, and just remove this and then see. If you run it, you will find the same thing here, right? You're getting the result here. So this is about the consumer functional interface. What is consumer functional interface? We have discussed how to implement its single abstract method through the traditional way and through the lambda expression we have discussed, and then we have discussed the use case of the consumer in the stream API as well. Now in this video we are going to discuss about the predicate functional interface, and we are going to discuss it in a very detailed manner. So let me try to go there, and first of all let me try to show you what is predicate is. Okay, so if we come here. Okay, so the predicate is a kind of functional interface and it has a single abstract method called test, and its return type is boolean and it is taking t as a argument. Okay, so you can also say that the predicate interface return a boolean value based upon the evaluation of the condition. Okay, predicate takes an argument of type t and return a boolean result. It has a single abstract method boolean test and it is taking a argument as t. Okay, so this is about the predicate. Now let me try to go to the IntelliJ, and there practically I will try to create the scenario where we'll try to implement the predicate interface, and then we'll see how we can override the test method of the predicate, and then with the help of lambda expression also we are going to implement this test method, and then we'll also see the use cases of the predicate in the stream API. Everything we are going to discuss in this video. So let me try to go to the IntelliJ, and in the previous video we have discussed about the consumer. So I have created this class called consumer functional interface demo, and there we have discussed the scenario of the consumer. Okay, now let me try to create one class here, predicate functional interface demo, something like that. Okay, now just add it, and let me try to walk you through the predicate first. So just go to this functional interface and then see. So you can see the predicate is a kind of interface and it is annotated with @ functional interface annotation. That means it has only single abstract method in it. So if you come down, you can see this. It has a single abstract method and its name is test. It is taking t as argument and its return type is boolean. Okay. So this is how the predicate interface is looking like. Now, if we'll come here to this class, let me try to create the man method here. And in the traditional way, how we try to implement an interface, the same way we are going to do here for the predicate as well. And later on, we'll try to see how with the help of lambda expression, we can implement the single abstract method of the predicate. And then later on, we'll see the use case of the predicate in the stream API. So let me try to do those things here. So first of all, just implement the predicate here in this class, and you have to provide one argument here. So let's say it is integer. Now you have to add the, or you have to override, right? You have to override the test method in this class. So just let me try to do that. Implement method. You have to implement this single abstract method, which is test. Just click OK, and we are good. Now, in this test method, you can do your own implementation, right? So it is taking integer as a argument, and let's say you want to put some condition here. So let's say if you're going to check that this integer is even or odd. If it is even, return true. If it is odd, return false. Okay, so that is what we are going to do here. So let's say integer and percent 2 double equal to 0, then in that case it is a even integer, then return true. Okay, else return false. Okay, so we have put this condition here in this method, and just let me try to put the colon here, semicolon, and yeah, we are good with the test method implementation. Now what we can do, if we'll come here to the main method, we have to create one reference of this class, and then with that what we can do, we can directly call the test method. Okay, so new predicate function interface demo. Okay, so we have created the object of this class predicate functional interface demo, and its name is functional interface demo. Now with the help of this object, what we can do, we can directly call this test method and provide some input here, which is an integer. So let's say we want to provide the input as 5. Okay, and what it will do, it will go to this test method. It will check if this input is even or odd. If it is even, it will return true. If it is odd, it will return false. So now again we have to create one variable to catch its result. So just create a variable called answer and just catch it. Now if you want to print it, you just print the answer here. So let's say provided integer is even, if it is even, it will come as true here. Okay, so we are printing the answer here. Now let me try to run this and then see. So just run this and just let me try to maximize this console, and here you can see that we are getting the result as false. The provided integer is even is false, right? The the input that we are sending here is 5 and it is not the even integer, it is a odd integer. That is means the answer that we are getting is false. Okay. Now let me try to change the input to 4 and then see. Here you can see the provided integer is even and the result is or the answer is true. So that means this test method is working fine, and this is how we can traditionally implement the predicate interface and override its test method, which is a abstract method. Now what I'm going to show you is with the help of lambda expression, we can directly implement its single abstract method, which is test. So how we can do that? In the previous videos, I have discussed that if you want to implement a single abstract method through the lambda expression, then you have to convert that method in the form of anonymous function first, and then with the help of lambda expression, you can implement it out. So that is what we are going to do now. So let me try to comment this thing. And now what you need to do, you need to comment this piece of code as well, but we need this method. Okay, so just copy this. Either you can copy it from here or you can go to the predicate directly, you can copy it from here. So just copy it, come here to this class, and why we're getting this error. Okay, yeah, we need to remove this implementation. Now directly we can implement this test method with the help of lambda expression. So you need to make this test method a anonymous function. Let me try to remind you that anonymous function is a function without the name and its return type or any modifier. So you have to remove the name of this function. So just let me try to remove, and you can remove the type of the input argument as well. So just remove this. Now you have to introduce the lambda expression here, which is arrow sign and its body. And in the body you can put the implementation that you want to do in the test method. Okay, so here you can see in the test method, this is what we were implementing. We were checking that the input integer, the input number is even or not. So the same thing you can do there. So let me try to copy this piece of code and come here and paste it out, and at the place of integer you have to provide the input that you are passing here, which is t. It is checking that if this t is odd or even. If it is even, it is returning true. If it is odd, it is returning false. Okay. Now you have to assign this whole lambda expression to the reference of the predicate. So let me try to create the reference for the predicate here. So predicate, let's say predicate equal to this, and we are good now. Now here let me try to check what is the error. Okay, so it is saying that it is not applied to the object int. Okay, let me try to check this predicate as an integer and then see, yeah, it is good. So you have to provide that this the argument that you are passing to the test method of the predicate is integer type. Then it will take that here and it will process your result. So here what we are doing is we have created one lambda expression, and this is the argument of the test method of the predicate abstract method. Okay, if you'll go to the predicate, let me try to show you. So if you'll go inside the predicate, you can see we have the test method, and this is inside the test method we have one single argument that we are passing here. The same argument you need to pass here, and then you have to pass the like you have to put the lambda expression, which is the arrow sign, and then in the body of the lambda you can put the implementation that you want to do in the abstract method. And that is what we are doing here. And with the help of this reference, what you can do, you can directly call the test method. So just paste it here, and then let's say in the test method we are passing the let's say number 5, and then see. So it will give you one result. Let me try to print the result directly here itself, and then see. So this integer 5 is not a even number. So this time we'll get the false here. So just run this application and then see. So here you can see in the console we are getting the result as false. Now if you'll pass the integer as 6, then this should give us the result as true. You can see this, right? So this is working fine, and with the help of lambda expression you can see you can directly uh, implement this test method. Okay, now if you want to minimize the code, you can minimize it out. So here you can see as in the argument we have only single argument, then you can remove this open and close parenthesis, and you can see still it will work fine. You can see you are getting the result. Now in the body you can see we have more than one line of code. Then in that scenario you need to put this body. But if anyhow you can convert this whole piece of code in a single line, then you can remove this body as well. So let me try to show you. So you can remove this whole if statement and convert this in a single line. So let me try to return it. Okay, so let me try to I think we don't need return here. Okay, let me try to put the return as well. Now run this again and then see. You can see you are getting the result. So you have reduced the code in a single line. Now we can see that we have reduced the code in a single line. Then we can remove this open and close bracket. So just remove it and remove the return as well and run this again. And here you can see you're getting the result. Okay. So this is how you can remove your boilerplate code using the lambda expression. So this is about the predicate functional interface. Let me try to summarize the predicate functional interface for you. So predicate functional interface is a kind of functional interface with a single abstract method test. Test is taking, let me try to go to the test and show you. Test is taking one argument and its return type is boolean. Okay, and with the help of lambda expression we can directly implement the test, and traditional way also I have showed you. Okay, now the time for the use case of the predicate, where the predicate is used. So in the stream API we can use the predicate. So let me try to show you those scenario as well. So now here let's say we have a list of integers and we want to find out even integers out of that list. So there is a filter method in the stream API which requires predicate. We can directly pass the predicate there and then filter out the events element from that list. So let me try to show you. So just let's say L and arrays dot as list, put some integers here. Let's say 5, 6. Let's say Here let it be till 6, or you can introduce the 7 as well. Now you have to import the list, and we are good now. Now just convert this list in the form of a stream, and then you want to filter out, right? So just you can see there is a method called filter in this stream, and this is taking the predicate as a argument. So if you'll go to the filter method, let me try to walk you through that. So just call this filter. If you'll go to the filter method, you can see it is returning a stream, and it is taking the predicate as the argument. So here what we can do is we can directly pass the predicate that we have created here. And this predicate, what it is doing, it is filtering out, or it is giving you the result for the even and odd numbers. If the number is even, it is giving the result as true. If the number is odd, it is giving the result as false. Okay, so this predicate we can directly pass here, and then what it will do, it will try to filter out the even number out of this list. Okay, and then directly what you can do, you can print it out. So let me try to print it out here. Go to the for each system.out.print. Okay, now run this and then see. So here you can see it is filtering out the even number for you, and it is printing out here. So what it is doing, let me try to explain you. We have a list of integers. This list has even and odd integers. Now we are converting that list to the stream, and then we are applying the filter method on it, and this filter method is taking the predicate. Okay, and we are passing this predicate here. What is happening here, when we are passing this predicate, it is directly calling the test method, and in the test method it is passing this element one by one, and whichever element is even, it is printing out that element, because it is for the even we are returning true. So that is why it is printing out the even element here. Okay, so this is the use case of the predicate in the stream API. Now what you can do, at the place of the predicate, you can directly call this lambda expression there. So just copy this lambda expression and paste it out, and then run here, and still you will get the same result. You can see it is giving you the even numbers. Okay, so this is about the predicate functional interface. Here in this video we are going to discuss about the supplier functional interface of Java 8. So first of all, what we are going to do here is we are going to discuss about the supplier functional interface, what it is, and which single stack method it holds, and what its return type is. So everything we are going to discuss, and then after that, practically we are going to create a class where we'll try to implement the supplier, and then see how we can call the single stack method of the supplier interface in the class, how we can override it, and then we'll try to move toward the Java 8. So with the help of lambda expression, how we can implement the supplier single stack method, and then we'll see what is the use case of the supplier in the stream API. So let's get started for that. So let me try to go to the slide where I have discussed about the supplier. So what is supplier? Supplier is nothing but it is a kind of functional interface which has a single stack method get, and its return type is t. So you can say that these interfaces don't take any input but produces a result. So you can see the single stack method that supplier holds is get, and it is not taking any input here, but still it has a return type, and its return type is t. So you can say that supplier produces a result type of t, and it has a single stack method get, and its return type is t. So this is about the supplier. Now what we'll do, we'll try to go to the IntelliJ, and then there I will try to practically create a class and implement the supplier there, and try to override the get method, and then we'll move toward the Java 8 lambda. With the help of lambda, we'll try to implement this get method, and then we'll see the practical use cases of the supplier in the stream API. So please allow me to move to the IntelliJ. So here let me try to go there, and let me create one class called supplier functional interface demo. Okay, and let me try to, first of all, let me try to walk you through the supplier. So go to the supplier. Here you can see this is a functional interface, and it has one single abstract method get, and its return type is t. Okay, so this is how the supplier is looking like. It is not taking any input, still it is returning something, and that something is of type t. Okay, now come here to this class, and first of all what we'll do, we'll try to implement, like this is the traditional way how we implement the interfaces, same way we are going to do here, and then later on we'll move to the Java lambda expression. So sorry, we need to implement the supplier here. Let's say type is integer, so we can only return the integer type from the get methods. So let me try to implement the get method here, and you can see that this get method is here, and we need to override it, and its return type is, you can see it is integer, the integer that we have provided here in the supplier, the same return type will get from the get method of the supplier. Now what we need to do, we need to override according to our need. We can override this get method, so let me try to override it, and let's say we are returning the number 100. Okay, and now let me create the main method here, and how we can call this get method. So we need to create the object of this class, and then directly we can call with that object. So let's say demo new supplier function interface demo. With the help of demo, we are going to call the get method, and this get method is returning an integer. So here you can create a integer variable. Okay, so let's say it is var, and now you can print it out. Okay, and run it, and then see. Let me try to maximize it. Here you can see in the console we are getting the 100 here. So without providing any input, still it is returning the value, right? And that value is of integer type here. So this is about the get method, and this is about the supplier traditional implementation. Now what I'm going to do is I'm going to remove this implementation from here, and with the help of Java lambda expression we are going to implement this get method, which is a single abstract method. Okay, so either you can remove it from here, or yeah, let me try to remove it, and let me try to comment out this piece of code. And now what we need to do, first of all, how we write the like how we implement the single abstract method of the functional interfaces with the lambda expression. In the previous video I already have addressed that. First of all, if you are going to implement a single abstract method using the lambda expression, then you need to convert that single abstract method in the form of anonymous function. So that is what we are going to do here. So first of all, let me again go to the supplier. So here it is opened, and copy this single abstract method, come here to the class, paste it out, and while you are going to make this anonymous function, you need to remove the name of the method and the return type, or you can say its modifier. So now it is anonymous function. You need to provide the lambda expression here, and then you have to provide the lambda body. Okay, let me try to put it in the main method here. Okay, in the body, let's say you want to return something, so just return the number. Let's say it is 100. Okay, and here what you need to do, you need to create the supplier. Let's say the supplier type is integer, so it will supply a integer out of this lambda implementation, or method implementation you can say. So let's say we have created the instance of the supplier, and we are assigning this whole lambda expression to the supplier instance. Okay, and this lambda implementation of this get method is returning 100. Okay, now with the help of supplier, what we are going to do, we are just going to call the get method, and let's say it will return a integer, so just going to create a variable integer here, and then hold the value that we are getting from the get method of the supplier. Now what you can do, you can print out this variable and then just run it again, and here you can see still we are getting the 100. If you'll change this value to 1000 and run it again, you will get it to the 1000, you can see. So what is happening here is, first of all, we are going to take the single abstract method, and then we are converting that single abstract method in the form of anonymous function, and then we are applying the lambda expression here, and then we are providing the lambda body. In the body, we are going to do the implementation that we want to uh, do in this method, right? When we are going to override, when we are overriding, sorry, when we are implementing the supplier in the traditional way, what we are doing, we are overriding this get method, right? And in the implementation, we were providing that its method is returning a integer, and let's say the number is 100. Similarly, we are going to do here, and in the body, lambda body, we are going to implement the same thing, right? That is what we are doing here, and with the help of this supplier reference, we are calling the get method, and then we are holding that value in the integer variable and then printing it out. Okay, now this is how, with the help of lambda expression, when we can implement the single abstract method of the supplier functional interface. Now here you can see we have only one statement, so we can remove this body here, open and close curly braces, and we can remove the return as well and come here, and still it will work fine. So let's say rerun it again and then see. You can see we are still getting the 1000. Now let's say you want to supply some other type. Let's say this time we are supplying the integer here, right? Now let me try to change it to the string, and let's say we are supplying the string here. Let's say it is some name like Ram. Okay, and the return type is a string, so we need to change our variable type also to a string, and then we are simply printing it out. Now if you run it, you will get the RAM here, you can see. So this is how you can implement the single abstract method, which is get method of the supplier functional interface. Now the time to see the use case of the supplier in the stream API. So let me try to show you one scenario. So what we are going to do, we are going to create a list of the integers. Okay, and there we'll try to convert that list into the stream, and then we'll see where we can see the use case of the supplier. Okay, so let me try to create that list here. So let's say it is list of integer, and let's say al equal to new. Okay, so here we are not going to create array list. What we can do, we can directly call the array dot as list, and in the list we can provide the values here. So let's say we are providing the values till 5 6, okay, till 6 only, and put a semicolon here, import this list. So we have a list of integers from 1 to 6. Now we are going to convert that list into the form of a stream, and then what we can do, we can call the find any, let's say, and then let's say like this stream does not have any value. Okay, it is going to find the value from this list. Like we have the list, it contains the value 1 to 6, and we are converting that list to the stream, and we are finding any value. If anything is not there, in that case what we need to do, we need to supply something. So let's say there is an option called or else get, and you can see this or else get method is taking the supplier as an input. Okay, so let me try to call this method, and here you can provide the supplier, and then it is good. Now before going to do that, what I'm going to do is I'm just going to go inside this method and show you. So you can see this is a method and it is taking supplier as the input, and it has some return type of T. Okay. So what we are going to do here is, as of now we have the values inside the list, but what is the case when we don't have any value? So when we are calling find any, it is not finding anything, then in that scenario it will supply something here. Okay, so what we are going to supply, let's say we are going to supply 100 if anything is not found. But directly we cannot supply 100 here, right? What we need to do, we need to provide the supplier here. So in the above example, okay, this is the string. Let me try to comment it out and create a supplier here, and that supplier we can directly pass here. And if anything is not there in the list, it will supply that value to us. So here let me try to create one supplier of integer type, and let's say supplier, and it is supplying, let's say 200. Okay, and we are not going to do anything here. We can directly call that supplier in this method. So copy it, paste it here. It will return an integer. Let's say we are going to create a variable, okay, of integer type, and then we are going to print it out. So let me try to print it and then run it and then see. So as of now you can see we are able to find any value from the list, and it is picking any of them. So it is picking first one, which is 1, and it is returning here. What is the scenario when nothing is there in this list? So let me try to remove everything from the list and then rerun this again and then see. So we have removed everything. If nothing is there, then it is picking up this or else, and it is going to the supplier, and this supplier is returning 200. That is what we are getting here in the response. So this is the one use case of the supplier. You can go to this or else get method and you can provide the supplier here, and it will give you that supplier result. Now in the place of this, what you can do, you can directly copy this lambda implementation and come here, paste it out, and let me try to, okay, let me try to comment this piece of code and provide that implementation directly here and then rerun this. Still you will get the same result. You can see we are able to see the 200. If you want to change this value, you can change it to 2000 and then rerun this and then see. You will get the 2000 here. So this is how the supplier is working, and these are the scenario. Like we have discussed about the traditional implementation of the supplier functional interface. We have overridden the get method, and then we see how we can use the lambda expression to implement this get method of the supplier functional interface, and then we see one of the use case of the supplier in the stream API. Okay, so this is about the video, guys. Hi everyone, Ravi this side. Welcome to Engineering Adda. In this video, we are going to discuss about the functional interface of Java 8. In the previous video, we have discussed about the supplier functional interface of Java 8. Here we are going to discuss about the functional interface. Now, first of all, what we are going to do is we are going to discuss about the function and what it is, and what is the single abstract method of the function, what input it takes, and what its return type. Everything we'll discuss, and then we'll try to go to the IntelliJ where I already have created one application. There we'll try to create one class for the function, and then we'll try to implement the functional interface in the traditional way and override the method inside it, and then see how it is working. After that, we'll move to the lambda expression. With the help of lambda expression, we'll try to implement the function single abstract method, and then we'll see what is the use case of the function in the stream API. So let's get discuss that, and let me go to the next slide and tell you something about the function. So the functional interface is a part of Java util function package which has been introduced since Java 8 to implement the functional programming in Java. It represents a function which takes in one argument and produces a result. Hence, this is functional interface takes in two generic namely as follow. T denotes the type of input argument and R denotes the return type of the function. So function is a kind of functional interface and it has a single stack method. Apply, it takes T as a input argument and its return type is R. Okay. Now this is about the basic of function. Now let me try to go to the IntelliJ and there I will create one application. Sorry, there I will create one class for the function like function interface demo, and then we'll brief you about the function first, and then we'll try to implement the function interface in that class. We'll override the method and we'll go to the lambda after that, and then we'll see the use case of the stream API, like use case of the function in the stream API. So let me try to create that class first, and one by one we'll discuss everything. So let's say the class name is functional interface demo. Now, first of all, let me walk you through the function. So if we'll go inside the function, you can see this is a functional interface and it takes two arguments, T and R. And here you can see it has one single stack method, apply. Apply takes T as argument, input argument, and it has the return type of R. Okay, so this is how the functional interface is looking like. Others method it has is compose, which is a default method, and then similarly identity. So all others are the default and the static methods. You can see the use case of them, but here we are going to discuss about the apply. Okay, so let me try to go to the class first, and how traditionally we implement the interface, the same thing we are going to do here. So let's say implement function here, and the two argument let's say we are going to provide is integer and integer. So we are going to input the integer and we are going to get the integer as a result of the apply method as well. Okay, so that is why we need to provide the integer here. Now we are going to implement the apply method, and in the, like, we have overridden the apply method. Now here you need to do the implementation. So here you can see in this apply method is taking a integer input argument. Let me change the name of this argument. Let's say it is X. Okay, so we are providing one input of integer type to this apply method, and let's say we are returning the 10 into X. Okay, so the return type is also an integer. Now create a main method here, and how we try to call this method, the same way we are going to do here. Okay, so what we'll do, we'll try to create an object of this class, and with this object we are going to call this apply method. So just let me create the object of the class here. Let's say it is demo and equal to new. Now with the help of demo we are going to call the apply method, and let's say we are providing 20 here, and then the return type would be 200 because it is taking the 20 as an input argument, multiply it with the 10 and then returning it. So what you can do, you can create a variable of integer type, assign those value here in this variable, and then simply print it out. So yeah, it is good. If you run this, you will see the result. So here you can see, okay, we are running something else. Let me try to run this main method, and here you can see the result. We are getting 200. We are we are inputting this 20 as an input argument to the apply method. It is going to this apply. multiplying this input by 10 and then returning back. Okay, so this is the traditional way of implementing a functional interface, or you can say any interface, and overriding the method inside it, which is a abstract method. Now, how we can utilize the Java 8 features like lambda expression to implement this single abstract method. So in the previous video also I have discussed about this thing. So if you're going to implement a single abstract method of the functional interface with the lambda expression, then what you need to do? First of all, you need to convert that single abstract method in the form of anonymous function. Okay, and then you can provide the lambda expression and then lambda body, and in the body you can do the implementation. So the same thing we are going to do here. So let me try to comment this piece of code, and what I'm going to do is, here you can see we have the method. Let me try to comment it out as well, and just remove this piece of code. And if you'll go to the function, this is the method, so copy this method, come here to this class, go to the main method and put it here. Now you need to convert this method in the form of anonymous function. So what is anonymous function? The anonymous function is a function without any name and any return type or any modifier. So remove everything from this anonymous from this single stack method and make it an anonymous function. So we are removing the name and the return type. Now it has a input of type T. So the type you can remove, and let's say it has one input. Now you need to provide the lambda and then the lambda body. So in the body you can do the implementation. So let's say we are going to return something. Let's say we are going to multiply the input by 100 this time, and we are returning it. So the input is T, we are multiplying it by 100 and then returning it. Okay, okay, the spelling of return is good. Return. Okay, yeah. Now what we need to do, we need to create a reference of the function and assign this implementation or assign this whole lambda expression to this function reference. So create a function, and let's say both of the argument are of integer type, and let's say the function reference name is function, and we are good. Now with the help of this function reference that we have created, we can directly call the apply method, and in the method we can pass the value that we want to pass. So let's say we want to pass 30 this time. So what it will do when we are passing 30 here, it will go to the implementation of this class of this single stack method, and here we have the implementation. In the implementation, what we are doing, we are multiplying that T, multiplying that input argument by 100. So the result would be 3000, right? So let me try to catch the result in a variable, and sorry, and then print that variable here. So yeah, we are good. Now run this and then see the result. So here you can see we are getting the 3000. So now again, if you want to minimize this piece of code, you can do, because it has only a single line of statement. So what you can do, you can remove this lambda body. So remove the lambda body, and also you need to remove the return here, and yeah, and because it has only one input argument, you can remove the braces as well. So just remove that and you're good. Now if you run this, you will get the same result. You can see 3000. So everything is working fine, and this is how lambda expression help us to avoid the boilerplate of code. Now we are working good, right? So what we have discussed about how traditionally we can implement the functional interface and override its method. And then we move to the lambda expression, which is introduced in Java 8. And the lambda expression help us in minimizing the code and writing the very concise code. Now the term stream API. So we'll see what is the use case of the functional interface in the stream API. Okay, so one of the use cases we will discuss, and then we'll wrap up this video. So what we are going to do here is we are going to create a list of integers. We'll convert that list in the form of a stream, and then we'll see the use case of the function in the intermediate methods of the stream API. So one of the methods that take function is map. So we are going to discuss map here. So let me try to do that. So what we are going to do is we are going to create a list of integer first. So just create a list of integer, and let's say its name is L, and we are going to use this array dot as list. Let me provide couple of integers here. Okay, 1 to 6. Import the arrays and the list as well. So we have created one array list, or you can say list of integers. Okay, now what we are going to do is we are going to convert this list in the form of a stream, and then the stream has a map function, and you can see this map method is taking function as an argument. So if you'll go to the map, let me try to go inside it and then show you. If you go inside the map, you can see it is taking function as an input argument, and its return type is a stream. So now what I'm going to do, I'm going to call this map, and in the map we are passing this function that we have created. Okay, and then see the result. So function, and then what we are going to do, we are going to call the for each, and in the for each we are basically going to print each element of the list one by one. So system dot out, and we are using the method reference here, so println. In the coming videos I will discuss about the method reference, so don't worry about that. So what we are doing is we have created one list of integer. It has the value 126, and we are converting that list in the form of a stream. Then we are calling the map function. In the map function we are passing this function, and then we are printing each element one by one. So what this function is doing, it is taking out the input, and it is multiplying that input by 100 and then returning as a result. So what will happen here is, let's say we are passing 1 as a input of this function, and it will go to that apply method of the function, and then in the implementation of the apply method, what we are multiplying each element by 100. So the first one will be 100 into 1, which is 100, and then second one will be 100 into 2, which is 200. Similarly, we have the 100 to 600 result. Okay, so let me try to run this and then see. Here you can see the first one is coming from the this. If you want to avoid it, you can comment it out. And then afterwards, what we have 100, 200 to till 600. Let me try to rerun this and then show you the result. So you can see from 100 to 600. So what is happening here is we have created a list, and then we are converting that list in the form of a stream, calling the map function. Inside the map, we are passing this function as an argument, and what it is doing is it is calling the apply method of the function. Inside that apply method, we are passing each element of the list one by one. What apply method is doing here is it is multiplying that element by 100, and then we are passing like we are calling the for each, and it is printing each element after that. So that is what we are getting here in the result. Now what you can do, you can directly pass this lambda expression to this map. Okay, and then you can get the result. So if you want to run this, or rerun this again and then see. Okay, let me try to rerun this. I have opted some other option, I think. Yeah, run this and then see. You can see the result: 100, 200, 300, 400, 500, and 600. So this is how the function is working, and we have discussed about one of the use case of the function in the Stream API as well. If you want to discuss, like if you want to practice, you can practice the other intermediate method of the Stream API where it takes the function. So you can go there and try to implement it. So this is about the functional interface and apply method. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.